But let me move on to also now the issue of permafrost. Perennially frozen ground, which never thaws out fully during the summer and remains frozen at depth throughout the year. It underlies something in the order of 25% of the land area of the continents in Europe and in Asia. The Antarctic also is covered by or underlain by permafrost, but 25% of the land area by this frozen ground. And here you see some massive ice underlying a layer of soil, which is the home for quite a lot of biodiversity, but also trees growing over these large lenses of ice and frozen ground. Also, this frozen ground does not allow a lot of drainage, so you find that there are bogs and rivers. Bogs and rivers in this permafrost area. And this is just a large area where ice has built up and burst through the surface. It's called a pingo, but that's the general sort of terrain. And this area of permafrost has started to be compromised and has decreased between 7 and maybe even a bit more, maybe 10%, since the beginning of the last century. The temperatures in the permafrost indicate what is going on, this melting. And here in Alaska, we see that the top of the permafrost, these depths here are down to 1 meter. And we can see that certainly in the last 50 to 60 years, there has been a steady increase in the temperature at various depths. And of course, as it approaches zero, then the ice and the frozen ground is melting, and this gives rise to all sorts of impacts in the Arctic itself. Here's a list of them. Hydrology. As the permafrost melts, so we are getting more of these lakes forming, thaw lakes. Drainage becomes a problem. There's more water. It has to be taken away out of the ponds. More rivers are developing and streams. That gives rise to a whole change in the ecology of the surface. Where we have human habitation, as the ice melts, it melts differentially. And if you've got roads or railways or other communications, runways for aircraft, these can be broken up and disrupted as the permafrost gives way and foundations crumble. Where you've got buildings on the permafrost and it starts to melt, these are the sorts of problems that you get. Buildings crack, foundations disappear, and habitability becomes a problem. Also, we heard that there is methane and also carbon trapped in the permafrost. The vegetation has, over time, decomposed. Methane has been produced, and there is obviously carbon matter. The methane is in the form of a hydrate that is under pressure, and it forms a solid material called the clathrate. And as the permafrost melts, so that methane is released back to the atmosphere. And here you see in a frozen lake, frozen bubbles of methane, which have been seeping up through the bottom of the lake as the permafrost has thawed beneath. At the moment, the tundra, the frozen ground area in the Arctic, contains very large quantities of methane. This is just one estimate, something in the order of 70 billion tons in the part of Arctic Russia that is covered by permafrost. And we know that methane is a very much more aggressive greenhouse gas, something like 24 times more aggressive than carbon dioxide, although it's much shorter lived in the atmosphere. And in the West Siberian plain, recent studies have shown that this is now becoming released to the atmosphere at a much more rapid rate. And submarine permafrost, as the ocean warms in the Arctic, that sea ice moves back, submarine permafrost is also releasing methane into the atmosphere. And one area of part of the submarine continental shelf off the Arctic, in the Arctic, has shown emissions in the order of millions of tons per year since about 2005. So we are beginning to see a significant increase in the amount of methane escaping from the permafrost regions, both submarine and on land, into the atmosphere. These changes of the permafrost are also making changes to the land ecosystems, and one comment here is that we are in for really quite a big ecological shift in the very, very near future as this melting takes place. And what happens to plants and animals, but particularly plants, is we get relocation. They just move away from the areas of the problem. The tundra is replaced by boreal forests, and species composition and other factors are now occurring in the north. So this scene of Arctic tundra, low, very, very small plant succession, very, very barren area, will be gradually replaced by boreal forest. And that is the sort of change that we are already witnessing and experiencing. But let me, in my final few minutes, turn to the issue of ice and ice sheets. What is happening to the world's glaciers? Well, they are melting at an increasing rate. A recent study of around about 180 glaciers from all around the world showed that over the last 50 years, the average thickness change has been negative, and the increase in that negativity has been much more prominent in the last couple of decades. So the cumulative mean thickness change here you can see is on average round about 14 to 15 meters of loss of ice. And in some cases, these have disappeared completely. In Alaska, you see here 1973, and then in 2006, this glacier has gone, completely disappeared. Take the case of a glacier in Norway, Briksdalsbreen. This is the situation in 2001 through to 2007, gradually retreating and disappearing. But don't be fooled. Glaciers, because they are mostly in mountainous areas, are affected by local climate. And in areas such as Alaska, where you get storms coming in from the northeast Pacific, this can actually override, in terms of precipitation, the loss by melting. And so you actually get a varied picture where some, in Norway, glaciers have been seen to advance as well as others retreat. You have to understand the local conditions before you can make some wide-sweeping statements. But by and large, the world inventory is one of loss. The great ice sheets. In Greenland, we need to understand what's happening there because it contains enough water, should it all melt, to raise world sea levels by about 8 meters. And over recent decades, again from satellite monitoring, we've seen a reduction of between 10 and 20%. A version of this diagram we've already seen, that the increase in the area of melting around the margins has expanded dramatically. That's the latest compilation that we have in 2007. And this is what we see on the surface of Greenland as this melting proceeds. Now we're getting water ponding and, of course, carrying away mass into the ocean. IPCC prediction is that if we have a 3-degree warming in the Arctic, then the balance in Greenland will change from one of small positive growth to one of serious negative decline. In other words, there won't be enough snow falling in the winter to make up for the winter melting, and Greenland is therefore in a terminal position. And although it's 3,000 years, make no mistake, year on year, the added contribution to sea level is really quite significant. So that really brings me to the impact of this melting ice on sea level. Just to show you what this might look like, excuse me, including the Antarctic, which is the far greater contribution. If all the ice were to melt, then we would have round about 200 feet of sea level rise. And against the Palace of Westminster, which is a familiar picture, a 10% and a 60% ice melt is shown here. I always show this to politicians because the first thing that they want to know is, where is my office? So we have to make a bit of an impact. Of course, this is not likely to happen in the near future, but the inexorable rise of sea level in key areas around the world is important. In the great deltas of the Irrawaddy and in, say, in the Maldives, in low-lying islands, in the Indian Ocean or the Pacific, this is a crucial issue. IPCC prediction is, as you see here, sea level rise by the end of the century, a minimum of 20 centimeters. Of that, 20 centimeters, something like 8 centimeters comes from the melting ice in the Arctic. The Antarctic is actually at the moment pretty negative. Very, very small amount of growth in the Antarctic ice sheet due to increased precipitation. But the melting of Greenland and Arctic glaciers, you can see Greenland accounts for half of the contribution and Alaska another 25%. So I'm going to end with this checklist of what is happening in the Arctic. Temperatures are rising. We haven't talked about snow cover, but it's reducing. Sea ice is reducing. River flow is increasing. We haven't mentioned that, but that's what is happening to get rid of all that melting snow and permafrost water. Glaciers are by and large decreasing, but not all. Ice sheets are definitely melting, and so is the permafrost. So, ladies and gentlemen, that gives you a roundup of what's happening in the Arctic. But let's have the last word to those people who live there. A native from Nunavut, which is the eastern part of Canada. When I was young, the old men used to say, there will be a time when it will be 12 months of summer per year with no freeze up and no thaw for 12 months. And they say, perhaps we will see this in the future. I think they were very prescient in using their traditional knowledge to make that statement. So, thank you all very much indeed. Thank you.